Hello, in this last video for Chapter 4, we're going to do a couple application problems using the derivative methods that we learned. So in this example, in the early stages of the AIDS epidemic during the 1980s, the number of cases in the United States was increasing about 50% every 6 months. By the start of 1983, there were approximately 1,600 AIDS cases in the United States. Had this trend continued, how many new cases would there have been in the start of 1993? So they gave us the equation A equals 1,600 times 2.25 raised to the t. We want to find the rate of change, so we want to take the derivative and then plug in 10 to represent 1993. So first of all, we have to figure out which is this. Now, 1600 is a number in front of a special case. So kind of like with our derivatives before, if you have a number in front, the number stays in front. If it was 1600x, then we'd be doing something like product rule. But since it's just a number like 1600, the number stays in front. Then, how do we take a derivative of a number being raised to a variable? That was our last special case. So step 1, rewrite it, 2.25 raised to the t, times ln to the base, which is 2.25, times the derivative of the exponent, so the derivative of 1t is 1. And multiplied by 1 doesn't change it, so 1 times 1600 is just 1600. Then we plug in 10 to see how it's changing in the year 1993. So I plug in 10 into the equation, and we get 4,314,482 cases per year. Now, if I plug 10 into the original, I can find out that it's predicted there to be 5,320,410 total cases. But if we want to find out how it's changing in year 10, that's when we plug into the derivative, which gives us 4,314,482 cases per year. In the next example, a little more complicated of an equation. The sales of Cyberpunk 2 arcade video game can be modeled by the logistic curve q to the t 10,000 over 1 plus 0.5 e to the negative 0.4 t, where qt is the total number of units sold t months after its introduction. How fast is it selling, let's say, 2 years later? So in this case, 2 years, we can plug in for 24 months. In this case, probably need to rewrite it a little bit. So I'm going to take the entire denominator, raise it to the 1, so if I move it up, it'll be raised to the negative 1. So again, if we rewrite it, it makes it a little bit easier. Then, let's see what we have. We have a number in front. We know what happens with derivative. We leave it in front. And we have stuff raised to a number. That would be chain rule. So the 10,000 stays in front, and let's do chain rule. The negative 1 goes in front. Inside stays the same. 1 plus 0.5 e to the negative 0.4 t minus 1. Minus 1 gives you negative 2 times the derivative of the inside. Now to take the derivative of the inside, the derivative of 1 is 0. And then to take the derivative of 0.5 e to the negative 0.4 t, we need that special case. So the number in front, 0.5, stays in front. The derivative of e to the negative 0.4 t, remember your special case. Step 1, rewrite it, e to the negative 0.4 t times the derivative of negative 0.4 t, which is negative 0.4. So again, we did 10,000 stays in front. We followed chain rule. The negative 1 goes in front. Inside stays the same of 1 plus 0.5 e to the negative 0.4 t raised to the negative 2, because negative 1 minus 1 is negative 2. Then we take the derivative of the inside, like chain rule says. Derivative of 1 is 0. But to take the derivative of 0.5 e to the negative 0.4 t, we have to take the special case of e. So the 0.5 stays in front. Rewrite it, e to the negative 0.4 t. Times the derivative of negative 0.4 t, which is negative 0.4. Now to clean it up a little bit, the negative 2 can go to the bottom. We can multiply the negative 1 times 10,000 times 0.5 times negative 0.4 and get 2,000 e to the negative 0.4 t as the numerator, and then the denominator 1 plus 0.5 e to the negative 0.4 t all squared. And if we plug in 24, we get 0.135 units per month. So after 2 years of sales, the instantaneous rate of change is 0.135 units per month. Sales were very slow. Thank you, and that concludes Chapter 4.